Welcome, and thank you for joining this webinar, Wireless Driving the Automotive Machine to Platform Transformation Executive Summary, prepared by Albert Research Team. Today, we're exploring one of the most profound shifts happening in the automotive world, the transformation of vehicles from mechanical machines into intelligent, software-defined platforms powered by wireless technologies.
But it can't all be smooth sailing. What are the major challenges and risks that need to be managed? Let's start with the technical ones. Latency and reliability seem to be recurring themes.
They are absolutely critical, and delivering them consistently is a major challenge. We talked about needing sub-10 millisecond latency for autonomous functions. 5G can deliver that, but doing so reliably everywhere all the time, that's hard. Think about driving through an urban canyon with lots of signal reflections or a tunnel, or even just network congestion. Maintaining that 99.999% reliability needed for safety-critical functions in these real-world, often harsh radio frequency environments is a huge technical hurdle.
And on top of that, you have all these different wireless systems trying to coexist in a small space.
Yeah.
The interoperability challenge.
Yes, managing the sheer density of wireless technologies in modern cars is incredibly complex. You've got cellular, 4G, 5G, maybe CV2X, Wi-Fi, possibly dual band, Bluetooth, UWB, NFC, maybe satellite links, TPMS sensors, all operating in relatively close frequency bands and physical proximity.
How do you prevent them from interfering with each other?
It requires very sophisticated RF coexistence engineering. You have to carefully manage power levels, timing, and potentially use advanced filtering to ensure that, for instance, a high-power Wi-Fi hotspot doesn't drown out a low-power, safety-critical V2X signal or a precise UWB ranging pulse. It's a constant balancing act. And then you layer on the global fragmentation issues with V2X standards, CV2X versus DSRC, which just adds another layer of complexity and cost for global automakers. Cybersecurity is arguably the single biggest non-technical challenge, and the risks are profound. Every single wireless interface, the telematics connection back to the manufacturer, the Bluetooth link to your phone, the Wi-Fi hotspot, that OTA update channel, the V2X antenna, everyone is a potential door for attackers.
An expanded attack surface.
Massively expanded. And attacks aren't just theoretical. Remote attackers could potentially exploit vulnerabilities to gain access to the vehicle's internal network, the CN bus, and interfere with critical functions. Hijacking OTA updates is a particularly scary scenario. Imagine malicious firmware being pushed to thousands of vehicles. That's why secure, cryptographically signed and verified updates are absolutely essential. Spoofing V2X messages to cause phantom braking or incorrect warnings is another major concern.
Do we have data on how successful these kinds of attacks can be?
Unfortunately, yes. Research has shown that certain types of context-aware attacks targeting AD systems, maybe feeding false sensor data or manipulating map information, can have success rates as high as 83.4% in causing the system to make unsafe decisions, often without alerting the driver. The potential consequences are obviously severe.
So what's being done to mitigate this? What are the requirements?
Mitigation has to be multi-layered, what's often called defense in-depth. It involves secure hardware components, secure boot processes to ensure only trusted software runs, intrusion detection systems monitoring the internal network, encryption for communications, and rigorous vulnerability management. On the regulatory front, compliance with standards like ISO 21434, which defines cybersecurity engineering processes for vehicles, and UNES regulations R155 and R156, mandating cybersecurity management systems and secure software updates, is becoming mandatory in many regions. Even technology choices, like using UWB for digital keys because it resists relay attacks, are part of the overall security strategy.
Let's quickly revisit the regulatory and standardization hurdles beyond cybersecurity. You mentioned spectrum fragmentation for V2X.
Yes, that global fragmentation is a real headache. The 5.9 gigahertz band, which is prime real estate for V2X, is allocated and regulated differently in the US, Europe, and Asia. This forces manufacturers to develop different versions of hardware and software for different markets, driving up costs and complexity, potentially by that 15% figure we mentioned earlier.
And the functional safety certification for new wireless systems.
That's another big one. Getting safety-critical wireless components, like that WBMS we discussed, certified to ISO 26262, especially to the highest level, ASIL-D, is a long, complex, and expensive process. It involves immense amounts of testing, documentation, and independent validation. While absolutely necessary for safety, it definitely adds friction and slows down the pace at which some of these advanced wireless innovations can be deployed compared to, say, consumer electronics features. So what does this all mean? The message is clear. Wireless is no longer an add-on. It is the infrastructure of modern automotive value. If you take away one thing from this review, Let it be this. Wireless is now the central nervous system of the automotive industry, and mastering it is essential to driving the future of mobility. Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert research team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.